So to start it off, we have Dino Dai Zovi, and he's going to be doing Macsploitation. And just to remind everybody, he is the co-author of Mac Hacker's Handbook, which was just published recently, I guess. In March, yeah. So it's good, new, fresh stuff, and I hope you enjoy it. This is a 20-minute breakout session, so he's going to be doing 20, and then we're going to have a couple other guys come up do their 20. So you'll see my ugly mug 2 more times. All right, without further ado, here's the guy you came to see.
All right, thank you. I have a little too much material for 20 minutes, so I'm going to kind of do a breakneck zip through slides and then a demo, and then you all can just kind of like see if you can absorb it later. So I'm going to be talking about some just Macsploitation with Metasploit, which is just extending a lot of the stuff that Metasploit has built in to hack Macs, because Macs are getting, increased market share. Their like web browser percentage is like almost at 10%. And the thing is, basically, enterprises really have very poor management practices for these. And if you're a pen tester, you want to demonstrate this. And to do that, you need good tools to own shit up. So what I'm going to talk about in this talk is just kind of go over some of the payloads and basically the Metasploit infrastructure that Charlie Miller and I, who's sitting over there, we wrote for our book, Mac Hacker's Handbook. Which is probably going to be relevant for like the next 2 months, so get it quickly. Because once Snow Leopard comes out, everything is just probably scrapped. And most of this code has been contributed to Metasploit. I'm a notorious vaporware author, so while it sits on my hard drive, it's not cleaned up, and I just haven't sent it to HD. So things like the Meterpreter's almost there, but everything else should be in there. Okay, so the first thing we needed was, in order to do like complex payloads, we needed a function resolver. You can only do so much with system calls, and so all the Windows payloads from Metasploit do the, the symbol resolution through PEB, where they find kernel 32, look up the symbols they need. So basically, we need this for OS 10, and the way to do that is to use DYLD, which is the runtime linker on OS 10. And even though Leopard claims to have library randomization, this is one that they conveniently forgot. So it's always at a known location, so you can just run through there, hardcode the address, parse through it, grab everything you need. The Mako binary format is very simple. It's much simpler than PE, which has like multiple different standards, sort of legacy standards kind of embedded in it. It's pretty straightforward. It's just basically some structures that define these are the segments that get loaded where in memory. So it's really easy just to scan through there, find the symbol table, and grab everything you need. And we use the what I call the ROR13 hash, which is the same hash function that just everyone uses, that came from LSD's Win32 paper from Black Hat, like in 2000. You'll see that just about everywhere. So the first thing that we do is we want to do like little high-level payloads, and writing all these in assembly is a big pain. And so what I did was made something just like the DLL-injection for Windows, but for OS 10. And on OS 10, instead of DLLs, you have what are called bundles. So the Mako binary format, which is analogous to PE or ELF, has different object types. And there's the executable, which is pretty obvious what that is. They have the dilib, which is a dynamic library, which is sort of like a DLL. It's kind of closer to that. But they also have this thing that's a little unique. It's called a bundle. And this is a specific binary format that's meant for dynamically loadable plugins. So things like Windows and Linux, you kind of just use DLLs or shared objects to do this. There's a specific format for OS 10. So basically, first stage just is basically a dumb remote execution loop. It takes machine code, executes it, and then basically just repeats. From there, we basically load in a little more code, which actually does the bundle injection. What this does is reads a compiled bundle file, which is a compiled plugin, and then just maps some memory, loads it in there. And there's actually these really 2 great function calls that are exported by the OS 10 linker, called create object file image from memory, which is kind of a mouthful, and NSLink module. So whereas the DLL injection stuff for Windows needs to do a variety of, tricks, contortions, whatever you want to call it, in order to load things directly from memory, the OS 10 linker just gives it to us as a function. So we just call this, and this will basically, unpack the binary image in memory as needed, and include and load up all the dependent libraries it needs. And so the third stage is basically whatever you want. And this is the actual bundle itself. And you can write your bundle code in C, C++, or Objective-C, and use any frameworks that are going to be installed on the system and write your attack logic or whatever you want to do. And so actually, I'll be like a broken record, kind of at this Black Hat, because I'll be talking about these bundles a lot, because they're my favorite things in sliced bread. Like, I just love just like loading into one process into another and just shooting them everywhere you need to go, because it's really easy to program them and lets you do really fun stuff. I'm going to make up some time and so skip some of this is a little more detail on what they do. But to give you an example of how easy it is to write one of these bundles, you can see just basically here's the skeleton code. There's just kind of my payloads kind of have this calling convention where when they're loaded, init is implicitly called. There's a run method, which is basically the main method that gets called with the socket. That's the connected socket, so you can use it and send back data as needed. And then if the module is unloaded, which is not always, may not always happen, the destructor will be called implicitly. So this lets you initialize, clean up, all that stuff. So what are some things that you can do? So the first thing I thought of was what I call take a pic of the VIC. Since all Macs have cameras built in, we may as well use them. And so it's actually really simple. You just grab some available code from the web. There's a great class called Coco Sequence Grabber. And it took about, I don't know, maybe about an hour or so to hack this into shape where I could just basically grab a single frame from the iSight and save it to disk. And the payload there's already a payload for this in Metasploit in the SVN, and it just sends the image right back to you and loads it up in on your system. So you can just go plop, plop. But of course, the victim will actually see the little green light go because that's actually connected electrically. So when that thing's on, the green light's on. But that's cool. But we want to do more. So of course, the holy grail of Metasploit goodness is the Meterpreter. And this is the most advanced payload they have. And one of the nice things is that you can bring along your own tools. You don't have to actually use anything from the remote system. You're executing everything from memory, and you're just grabbing all the resources, listing processes, setting up network tunnels, whatever you need to do. And you can also include other libraries with it that can get loaded. So it's basically better than a shell because there's not a shell running, and it's also in process. So if someone looks at the processes, they just see the target application is still running. Same thing. And you can do pivoting with it. We have like a little cool build here. You connect, attack the machine, and then basically surf through it to the local intranet. So here's basically how Meterpreter works for Windows. Exploit the DLL-inject payload, upload the interpreter DLL, and then you upload sort of the Meterpreter side components and associated script modules to actually create the glue. And then you have data channels which you communicate over. So Macterpreter is what actually Charlie Miller worked on, and basically is a port of Meterpreter to OS X. And basically this uses kind of the inject bundle functionality to do all the Meterpreter magic. And he added just a separate extension that's Mac API, which is basically just the port of the standard API to all the Mac stuff. Actually, at this point, I talked to HD last night. He said that the POSIX Meterpreter is just about almost done. I think it was finished like a couple nights ago. So basically what we're going to do is just merge a lot of this with the POSIX Meterpreter, and so it'll work the same on Unix and OS X. There's only some differences on the OS X one, whereas the thing that kind of sucks is you can't do process migration. And this is because of the sort of the architecture of OS X, where and the security model of accessing other processes' memory. So like on Unix and Windows, if the user owns a process, you can open up that memory and just do whatever you want to it. Whereas on OS X, you can't unless you're root. Even if you are, have privileges to attach to the process, you're not going to be able to get access to what's called the mock task port. And this is the port this is the kind of handle that gives you a full control over it. And that's sort of one of their just security restrictions. They're actually working on tightening up. So even on Snow Leopard, I expect that this will actually be even a little more hard to do. But for now, if you're root, you can do anything. So it kind of makes it a little easier. All right, so let's get to some demo goodness. All right, I'm going to open a betting pool to see if who thinks the demo will work and who thinks it won't work. This is the first talk of the day. I'm betting it's not going to work. Let's see. Okay. Everyone can see the text on the terminal, right? Resolution's like, my grandmother can read it high. All right, I can use this one. Okay, try this one. Yep. Ah, cool. Okay, so I'm using just a pretty ancient at this point, QuickTime RTSP Stack Overflow, just because it's a really reliable exploit, and so it's sort of like the decom bug for Windows, where it's just like the one that everyone uses, that I just use for every demo because it's just well behaved. Okay. So we can see basically the exploit executed. We sent all our stages, and we now have the Meterpreter session. So let's kind of play with it a little bit here. All right. So it's basically the same as the normal Meterpreter. However, there's one extra command that we added here called take pick. So let's see what that does. Just to show you, yeah, LS and PS and all the standard things you'd expect still work. Smile for the camera. It just takes a little while because the camera is attached to VMware, and this laptop is not exactly speedy. Okay, error. Yes, I win. We're just going to try one more time. Just zip through it here and see what happens. Perhaps I should have given a little more memory to this virtual machine. All right, looks like that's how it's going to be today. Always be prepared. This is a simulation of what it would look like if it actually worked. And for the record, this worked perfectly like 45 minutes ago. But the thing I didn't test is resuming from sleep or from a pause VM and making sure the video still worked. So that's what I'm blaming it on. It's not my fault, it's VMware. So for the book, we wrote up a number of exploits. So some of my favorite exploits over the years. First one is MDNS responder bug. This is the the default install remote route through the firewall bug that seemingly no one really noticed. And when it got fixed, it was like, an MDNS responder bug. But this bug is a lot of fun. It works it's only in Tiger, but if you find some old Tiger machines, basically this will just, it's local subnet only, but it's boom, remote route, very reliable. It's great. Then there's the QuickTime RTSP bug, and because we're both obsessed with Pwn to Own, the bug that I used to win Pwn to Own and the bug that Charlie used to win Pwn to Own, and basically a number of these payloads. So these are, I'll say about 60% of this slide is in Metasploit right now, and I'm going to try and get the rest in there as soon as possible. So if there's any questions, let me know, or hunt me down. I think I have 3 minutes for questions. Oh, I'm a horrible shill. I felt like I was shilling the book a lot, but I guess I should do a little more. If you'd like to buy the book, there's a big stack of them on the little book desk upstairs. And I'll volunteer Charlie to sign it. You guys see Charlie right there? Yeah, that's him. You just walk up to him with the book, he'll sign it. I'll do the same. But that I sacrificed a year of my life for that book, so hopefully it gives you at least 10 minutes of entertainment. Any other questions? All right, cool. Well, thank you very much.